Hello and Assalamu alaikum. Let's begin with our inaugural lesson of Candela Academia involving an introduction to vectors. Okay, so firstly, let's ask the very important question that what is a vector, right? I mean, what do vectors represent, or what's the definition of a vector? Well, if you've been studying physics, you would have been led to believe that vectors, you know, have uh, a direction and a magnitude. But see, many students, what they fail to do is they fail to realize that there's an important distinction between vectors and vector quantities. So this is the appropriate definition that's taught in physics, that vector quantities have a direction and a magnitude. Now, a quantity is something that can be measured. It can be, for example, a velocity. It can be, let's say, it can be displacement. Yeah. It can be acceleration, force, right? So these are vector quantities, and vectors are used to, represent these quantities. They're a vectors are a mathematical object, right? Which are primarily used to represent a direction. Okay, now notice two words over here, primarily and direction. I want to focus your attention on these two words, and also an omission that I've made, which is magnitude. I haven't mentioned magnitude in my definition, and that's on purpose, because you see, I've said that primarily vectors are used to represent a direction, right? Which means that vectors can have secondary functions as well, which means they can have a magnitude associated with them, right? But that may not always be the case. But vectors will always give you or represent a direction, right? This really small distinction that I'm making, it may seem insignificant right now, but when we kind of like talk about the different kinds of vectors, like the basic kind, like position, direction, and unit vectors, this distinction, this difference is really necessary to distinguish between them, right? And it will become apparent once we start discussing, position, direction, and unit vectors. Okay, so vectors will always give you a direction, right? They're primarily used to represent direction, but they may also be used to represent a magnitude, or they can have a magnitude associated with them, right? So let's move on to the let's move on to the first type of vector that we're going to be discussing in this video today, and it's the position vector, right? It's the position vector, right? And a position vector is what its name implies, right? It's used it's used to, right, represent or give the position of a point in space. And what do I mean by space? This isn't our space. This is the mathematical space that we're talking about, like the XY axes, right? So all of this stuff covered by the screen, it's space, right? For example, let's make a point over here, right? Let's make a point A over here. Now, I wanna give the position. I want to tell someone the position of this point A, right? So how do I do that? Well, first of all, I need a reference frame, right? And a reference frame, right, is basically like you can draw draw a set of draw a set of axes, right? The X and Y axes, to be specific, right? And any sort of drawing like this would have an origin, right? And this is labeled O. So to define the position of A, we need to choose a reference frame, right? And for example, I've chosen this reference frame with an origin at this point. And now I can basically what I can do is I can define the position of A relative to this point O. So I made an omission here in the definition. It should be, it's used to represent or give the position of a point in space relative to another point in space or relative to a given reference frame. And you can just think of reference frames as, coordinate axes, X and Y, right? Now, let's say the position relative to this origin O is at the point A. The X coordinate is, let's make it, I don't know, let's make it 4. And here, the Y coordinate, let's make it 3, right? So to get to this point A, what I'm saying, what you need to do is, first, you want to travel in this direction, the X direction, 4 steps, right? And once you get over here, you can travel in the Y direction and 3 steps and get to the point A. So the way you represent this information in vector form is either in the form of a column vector like this, 3, 4, right? Or you can represent this in the ij notation, 3i plus 4j, where I and j are just unit vectors, which unit vectors in the direction of the x and y axes respectively, right? Well, we're getting ahead of ourselves. We haven't discussed unit vectors here, but you may have seen this notation before. So let's just focus on column vectors, right? So any vector can be given in this form, x and y. It has an x component and a y component. And since you may say that, okay, this vector 3, 4, right, this is just the coordinate of the point A. So can vectors be thought of as coordinates? And the answer to that question is yes and no, because it basically depends upon the situation, right? For example, now in this x and y axis, in this grid that I have, in this coordinate reference frame that I have, the point A is definitely given by, right, these coordinates 3 and 4, right? But let's say, and the position vector of A relative to this origin, let's call that vector OA, right, is gonna be 3, 4, this column vector. But let's say in this same reference frame, I had a point, let's say, I had a point vertically. Oh, sorry, I had a point right here, right, on the y-axis. I had a point B on the y-axis. Now the coordinate, and this point is like exactly in line with point A. The x values are the same. So the coordinates of this point would then be, it would be, the y value would be, wait. So I kind of messed that around. That was my mistake. So it's 4 and should be 3, and this should also be 4 and 3, right? Because I defined it like that. Yeah, 4 and 3. So the orange point B, would be the x value would be 0 and the y value would be 3, right? So that's the coordinates of this point B in this frame of reference, in this coordinate frame, right? So now if I were to find a vector that links B and A, which basically means that if I were to say that, you know, I were to define the position of A relative to this point B, not this point O, so it wouldn't be 4, 3, right? It wouldn't be 4, 3, because to travel from B to A, since it's exactly in line, the y values are the same, I just need to move 4 steps in the x direction, right? So BA, the vector BA would actually be, let's say you move 4 positive steps in the x direction and 0 steps in the y direction, because it's exactly level with the point A with respect to the y-axis, right? Point B. Okay, so the vector BA would then be 4, 0. But notice that 4, 0 is, while it is a vector, it's not the coordinates. It's not the coordinates of the point A. Okay? It's not the coordinates of the point A. So there's this distinction between vectors and coordinates. If you're talking about position vectors with respect to the origin of the frame of reference that you're kind of defining all these vectors and coordinates in, then a vector, a position vector, and a position vector relative to the origin and the coordinates of the point that you're kind of drawing the vector to, the vector and the coordinates are going to be equivalent. But if you're kind of measuring the position vector relative to any other point besides the origin, the coordinates, right? The coordinates and the position vectors are not going to be the same. So that's a very important distinction that you need to make. Okay, so now notice that in this, right, in this position vector OA, let's talk about OA over here. Okay, let's talk about OA over here, right? It has this angle, right? And you can easily calculate this angle using sine and cos, right? So we have this opposite side, it's 3, and you have this adjacent side, which is 4. So tan, let's label this theta. Tan of theta equals opposite side 3 over 4, adjacent side. And you can easily calculate the angle like this. So you basically have the direction, and if you were to talk about the magnitude, you could use the Pythagorean theorem to calculate the magnitude as well. So the magnitude of any vector is given by this notation. You basically draw these absolute value signs like this, and it's given by the Pythagorean theorem, right? So it's gonna be 3 squared plus 4 squared, the whole of it is going to be under rooted, right? So it's going to be 9 plus 16, that's 25, and it's going to be 5. Okay, so now a position vector gives you the magnitude, which is the magnitude. Now I've been using this word magnitude for a very long time, but without defining it properly. The magnitude is just a numerical value assigned to any quantity, and in this case the magnitude is the numerical value assigned to the length of this vector, right? So the length of this vector is 5, and the direction theta is given by this thing, theta, right? So you know the magnitude and the direction. So position vectors usually give you both the direction and the magnitude, right? But I said that may not always be the case, right? That may not always be the case. So what other cases do we have in which we can have vectors that represent only directions and not magnitude? Well, those are called direction vectors, right? Now, direction vectors may not give you the exact magnitude all the time, right? For example, let's make our axes again. Let me use blue, right? X, sorry, my bad. Y and X, right? And we have this kind of vector going to point A, right? We have this vector going to point A, and this was 4 steps, this was 3 steps, right? We have this vector, this was the origin. OA is equal to 3, 4, right? Oh, sorry, 4, 3, my bad, right? Now, this is the position vector that takes you from the origin to A. This is the position vector of A relative to the origin, right? What about its direction? What about its direction, right? Now, if I were to, let's say, half this vector, right? I were to make a point over here. I were to divide this vector into 2 equal parts, right? I make this point B over here. Now, halving this vector would mean that I would be OB would be half this original vector, half of OA, which would just be half 4, 3, which would be 2 and 3 over 2, right? Notice, now having it would, let's talk about the direction theta, right? So tan theta for OA, let's write OA, would be opposite side and adjacent side, it would be 3 over 4, right? So theta OA would be tan inverse 3 over 4, whatever that is. I'm not going to calculate it right now. And tan, let me just choose a different color, and tan theta OB would be, opposite side would be 3 over 2 over 2, right? But we can just reciprocal that, right? And this would be 3 over 2 into 1 over 2 equals 3 over 4. And theta OB would be tan inverse 3 over 4. So what this proves is, what this shows is theta OA, the direction of OB is equivalent to theta OA, right? So the direction is the same. So direction vectors are kind of like this. Direction vectors are usually used to direction vectors are usually used to denote a direction, not the exact magnitude. So if I were to use OB to represent OA, if I were to use OB to represent OA, then I would not be giving the exact magnitude or the exact position of OA in terms of magnitude, right? But I would be giving the exact direction, right? So I would be giving half the information. So that's what a direction vector is, right? And you can mess around with by multiplying OA by any number, any integer or rational number, or even an irrational number, and the direction will always remain the same, right? And we can do a proof of that in future videos, right? And this video is kind of getting a bit long, not as long as as I imagined, but let's just quickly finish off with unit vectors, right? And let me just define this, and we'll go over it in detail in future installments, right? Unit vectors are vectors, and whenever I underline something, that means that is the thing being defined. If I were to use unit vectors in a sentence and underline that, that would mean that unit vectors are the ones being defined. Are vectors that have a magnitude of 1. So unit vectors are basically a special kind of direction vector. They may give the direction, they may be used to define the direction of a proper position vector, right? But they have a magnitude of 1, and having this magnitude of 1 is actually very useful, and I'll show a few examples in future installments when we discuss unit vectors in detail and how to calculate them. I'll show why having vectors of magnitude 1 are actually useful. So that was it for my first video. Thank you very much for watching. Please share and subscribe, right? Share this video with your friends and leave a few comments down below. I would love your feedback on my teaching style. Thank you very much for joining. Allah Hafiz.